All right, so this is inside the actual control unit itself. Whenever we take the front cover off and whenever we deal with anything inside, we want to make sure the power is shut off to this control unit. You never want to touch anything or take this cover off without making sure the power is killed to this control unit. All right, when you take the front cover off, there's a display ribbon cable that plugs in over here. You want to make sure you unplug that and you just don't have the display just hanging there. You don't want to damage the display ribbon cable or the display itself. So it's always important just to take that display off. All right, we're looking down here at the actual terminal bar, and from right to left, we have our power coming into the unit, so that's our 120 volt coming in. Then we have our high voltage relay for our ORP, that's right here. Then we have our high voltage relay for our pH feeder right here. And then what we're looking at is this cord right here. This is our backup relay for our salt system or for our liquid chlorine pump. You can actually tell the controller whether or not this is going to be an auxiliary ORP relay, or it could actually be programmed as the primary ORP relay. These controllers out of the box, this high voltage ORP pigtail right here for the wiring going into that terminal bar, that is going to automatically be your default primary ORP relay, but you can go into the programming of the control unit and tell the control unit that this auxiliary relay is actually going to be the new primary relay. So you can tell it to do either or. All right, when we're hooking up these backup relays, it's important to make sure there are 3 terminals, number 1, number 2, number 3. We are always going to be utilizing the normally open and the common when we're hooking up a backup feeder. All right, this is the same method we use if we're hooking up one of our aquatic salt systems, as well as, of course, this backup relay. So essentially, when there's not a demand for chlorine, that circuit is open. When there's a demand for chlorine, it closes that circuit, it engages that relay, and it's going to kick on that backup feeder. The importance of having a backup feeder is if for some reason the salt system ever can't keep up, high demand for chlorine, heavy bather load, crazy busy day, high demand, this controller will have an auxiliary chemical feeder to where it will automatically kick on at a lower ORP set point. You will set an auxiliary set point at a lower set point than the primary ORP, to where this controller will automatically activate the backup feeder whenever there's a time that the salt system can't keep up. It's very important to have this. Our CAT 4000 units and up have these auxiliary relays. Our CAT 2000s, they do have a relay, a low voltage relay such as this. However, it is activated when the primary relay is activated. You don't have an auxiliary set point for a CAT 2000. It's strictly the CAT 4000s and up, HCC 4000s and up, that have that auxiliary relay, that auxiliary set point that can be programmable in the actual programming of the control unit.